Hello friends, you are welcome. Let us look at quadratic inequality today. So you look at this inequality, x squared plus x minus 12 is less than or equal to 0. Quadratic inequality, you solve like quadratic equation until you come to the end, then you see a little difference I will have there. Okay, now quadratic equation by factorization, we know we look for two numbers whose sum is x and whose product is minus 12 x squared, and what we have 4 and minus 3, so I have x squared plus 4x minus 3x minus 12 is less than or equal to 0, because 4 minus 3 is 1 and 4 times minus 3 is minus 12. If you want to know how we are able to get these two numbers, you can go to our video on factorization of quadratic equation. That is where it is explained. So this is what you will do. Then you take them in pairs. What is the common factor of these two? This and this, x is common. So if you factor x out here, you have x plus 4. Here you have minus 3 common. You have x plus 4 is less than or equal to 0. So we're going to have x minus 3 and x plus 4 is less than or equal to 0. Okay? If it is an equation, we would have just said x minus 3, 0, and x plus 4, 0, if this was equation. But because this is an inequality, it is wrong for you to do this, because it is not, both of them are not going to satisfy this inequality when it is less than or equal to 0. So what are we going to do? We are going to assume it to be equality sign. If you find x here, assuming this is an equality sign, x will be equal to 3, and here x will be equal to minus 4. Okay? Now, you know in our number line, we are going to have, you identify these 2 points, 3 and minus 4. So let's say this is minus 4, you have minus 3, you have minus 2, you have minus 1, you have 0, 1, 2, and 3, of course 4, maybe 4, and then minus 5. Okay, the 2 points are minus 4 and 3. So these are the 2 points. So you identify these 2 points on a number line. If we do that, you see that we have 3 regions now. The region less than minus 4, the region between minus 4 and 3, and then the region greater than 3. So we are going to pick one value from this region, another from this region, and that from this region, to substitute in the original inequality and see which of them is going to satisfy the inequality. That is what will determine how we are going to represent these two things. Okay, so if we pick a number in the first region, which of course minus 5 is in this region, so if we pick a minus 5 here, if I substitute minus 5 here, I have minus 5 squared plus minus 5, then minus 12 less than or equal to 0. 5 minus 5 squared is 25, minus 5 minus 12 is less than or equal to 0. 25 minus 5 minus 12 will give us what? Minus 17 is less than or equal to 0. You have 8 is less than or equal to 0. 8, is it less than 0? No, 8 is greater than 0, so this is wrong. So this region is out of it. That means that from here, we cannot see that x is less than or equal to minus 4. Instead, because x less than minus 4 is minus 5 and it did not satisfy it. So this region is out. So because of that, I can therefore simply say that x is greater than or equal to minus 4. Let's check greater than minus 4. Let's check here. Let's check a number here. Maybe let's just pick 0. That's the simplest one we can pick. 0 is in this region. So if I substitute 0, 0 squared plus 0 minus 12 less than or equal to 0. This is 0, this is 0, minus 12 is less than or equal to 0. Minus 12 is less than 0, yes. So this is correct. So this region is correct. So I can say that x is greater than minus 4. Greater than minus 4 is minus 3, minus 2, minus 1, and so on. Then let's check this other region. 4 is in this region. If I substitute 4, okay, if I substitute 4, I have 4 squared plus 4 minus 12. It's less than or equal to 0. 4 squared is 16 plus 4, you have 20 minus 12 is less than or equal to 0. 20 minus 12 we have 8 is less than or equal to 0. And this is wrong, so this region is not satisfied. So x is greater than or equal to 4, but x is less than 3 because greater than 3 did not satisfy. So this one remains less than or equal to 3. You see that? So this inequality less than or equal to does not apply for the two of them. So you can just use this number line to know which one is going to be less and which one is going to be greater. So we have been able to identify the x is less than or equal to 3 or x is greater than or equal to minus 4. So that is it. Let's look at one more. I have x squared minus 12x plus 35 equal is, let's say, greater than 0. I said you can solve like quadratic equation. So I can say x squared minus 12x plus 35 is not equal to 0 because it's greater than 0 here. So look for two numbers that when you add will give you minus 12 and when you multiply will give you 35, and those two numbers are minus 5x and minus 7x plus 35 is not equal to 0. If you want to know how we get these two numbers, go and watch our quadratic equation by factorization. You will understand it from there. So what is common here is x into x minus 5. If you remove x from here, you have x minus 5. If you remove 7 from here, that's the common factor, you also have x minus 5 is not equal to 0. So we're going to have x minus 7 and x minus 5 is not equal to 0. And I said, if you separate it, x minus 7 is not equal to 0, x minus 5 is not equal to 0. But the question is, are we going to put greater than here and here? No, it depends on which one satisfies the inequality. So here you say x is not equal to 7 and x is not equal to 5. So what is x? Go to a number line, identify 7, you have 5, 6, 7, 8, 4, this is 5, this is 7. Okay, now we have three regions: the region less than 5, the region greater than 5 but less than 7, and the region greater than 7. So we'll check this region to know if it satisfies this equality. Pick any number within this region that is less than 5. Sorry, if I pick 4, I substitute 4 here. Let's check. 4 squared minus 12 times 4 plus 35, is it greater than 0? Let's see. 4 squared is 16 minus 12 times 4 is 48 plus 35, is it greater than 0? 16 plus 35 will give us 51 minus 48, is it greater than 0? 51 minus 48 is 3, greater than 0. This is correct. So this place is correct. That means if we use any number less than 4, less than 5 is correct. So this thing can say to be x is less than 5, irrespective of what you have here. X is less than 5 is satisfied here. Then let's check this region. We can use 6 for the second region. If I check 6 squared minus 12 into 6 plus 35 greater than 0. 6 squared is 36 minus 12 times 6 is 72 plus 35 greater than 0. 35 plus 36 is 71 minus 72 greater than 0. 71 minus 72 is minus 1 greater than 0. Minus 1 is not greater than 0. So this region is not satisfied. So x is not greater than 5. That is why this one is correct. X is less than 5. Okay, let's check this other region for the second one. Above 7. Let's check this region. We can use 8. We'll use 8. Remember, this is what we're substituting. 8 squared minus 12 into 8 plus 35. Is it greater than 0? 8 squared is 64. 12 times 8 is what? 96 plus 35 greater than 0. 64 plus 35 is 99 minus 96. Is it greater than 0? 99 minus 96 is 3 greater than 0, and 3 is greater than 0. So this is correct. Any number greater than 7 is correct for x. So x is greater than 7 and x is less than 5. So this is how we get the range of values of x for a quadratic inequality. You don't just assume this. So you have to check the region that satisfies it. We are going to definitely have 3 regions. So you see x is greater than 7 and x is less than 5 will satisfy this inequality, irrespective of what you have here.
Isn't there anyone who knows what Christmas is all about?